In 1977, NASA launched a mission that would reach farther than anyone had ever imagined. Two spacecraft, Voyager 1 and Voyager 2, were sent out to explore the edges of our solar system. But as the decades passed and the Voyagers drifted into interstellar space, the data they returned would baffle even the most experienced scientists. Mysterious readings, strange signals, and eerie patterns have led some to believe that what Voyager uncovered could alter our entire understanding of the universe. The Voyager project started with a clear goal: send robotic explorers to the outer planets and gather close-range observations of distant worlds. Launched just weeks apart in 1977, Voyager 1 and Voyager 2 were outfitted with sophisticated instruments to photograph planets, analyze magnetic fields, study atmospheric conditions, and measure cosmic radiation. One of the reasons the mission was possible at all was because of a rare planetary alignment, a window that only opens once every 176 years. This allowed the probes to use gravity assists to swing from one planet to another, conserving fuel while gaining momentum. Each spacecraft also carried a now iconic golden record, a time capsule of sorts with greetings, music, and images from Earth meant for any intelligent beings that might come across them. At the time, few imagined these probes would still be communicating with Earth nearly 50 years later. NASA engineers designed the Voyagers with radioisotope thermoelectric generators, devices that convert heat from decaying plutonium into electricity. This let them function far from the Sun, unlike solar-powered craft. While Voyager 1 was set on a course to leave the planetary plane after Saturn, Voyager 2 continued on to Uranus and Neptune in what NASA called the Grand Tour. Milestone discoveries and early surprises. Both spacecraft surpassed expectations almost immediately. When Voyager 1 reached Jupiter in 1979, it sent back breathtaking images of the gas giant's massive storms, including the swirling Great Red Spot. It also revealed volcanic activity on Io and icy terrain on Europa, hints that subsurface oceans might exist beneath its frozen shell. Voyager 2's path brought it to Jupiter shortly after, collecting additional data from different angles and adding to the picture. Both missions then used Jupiter's gravity to slingshot toward Saturn. In the early 1980s, the spacecraft sent back detailed views of Saturn's iconic rings. What scientists thought were uniform bands turned out to be a complex system of ringlets, gaps, and twists. Voyager revealed strange phenomena like spokes and clumped particles behaving in ways no one had predicted. Voyager 1 moved onward, diving out of the planetary plane and beginning its journey toward interstellar space. Voyager 2, meanwhile, continued toward two less explored worlds. Voyager 1's interstellar journey. Voyager 1 left the realm of the outer planets and began heading toward the edge of the solar system. Along the way, it kept gathering data on cosmic rays, magnetic fields, and the vast emptiness beyond the planets. One of the most famous moments in its journey came in 1990 when Voyager 1 turned its camera back toward Earth and snapped the iconic pale blue dot photo. Our planet, barely visible from such an immense distance, appeared as a tiny speck suspended in a sunbeam. The image became a powerful symbol of Earth's fragility and the vastness of space. As Voyager 1 moved farther from the Sun, scientists began focusing on its readings of the heliosphere, the protective bubble formed by the Sun's magnetic field and solar wind. Eventually, in 2012, the probe crossed the helipause, the outer boundary of the Sun's influence, and entered true interstellar space. It was the first human-made object to do so. What it found there was unexpected. The space beyond wasn't as silent or still as scientists had imagined. Voyager detected plasma waves, background noise, and strange fluctuations in particle density, signs that the interstellar medium is more dynamic and active than once believed. Voyager 2's historic encounters. While Voyager 1 was leaving the solar system, Voyager 2 took the road less traveled. After passing Saturn, it set a course for Uranus, arriving there in 1986. Voyager 2's flyby revealed Uranus to be unlike any other planet, tilted on its side with a strange magnetic field and unexpected ring systems. It also discovered new moons and showed that the planet's atmosphere was colder and less active than expected. 3 years later, Voyager 2 visited Neptune. The images it returned showed deep blue clouds, massive storms, and winds faster than any seen elsewhere in the solar system. On Neptune's largest moon, Triton, Voyager spotted active geysers spewing icy material from the surface, evidence of internal heat and potential subsurface activity. These discoveries at Uranus and Neptune marked the first and so far only close-up studies of these planets, providing invaluable insight into the diversity of our solar system. In 2018, Voyager 2 followed in its twin's path and crossed the helipause, entering interstellar space and offering confirmation that the region beyond the Sun's reach is anything but empty. Strange signals and unexplained phenomena. One of the most curious findings from both spacecraft has been the behavior of magnetic fields near the solar system's edge. Voyager 1 recorded strange magnetic hums and irregular vibrations once it crossed the helipause. Initially, researchers thought they might be glitches, but the consistency of the data proved otherwise. Voyager 2 detected similar phenomena: sharp changes in magnetic orientation, sudden shifts in particle flow, and pockets of turbulence that did not match established models. These findings forced scientists to rethink their understanding of the heliosphere's shape and how it interacts with the interstellar medium. Could there be unknown forces or objects affecting the outer edges of our solar system? Some theories suggest that nearby stars, supernova shock waves, or even dark matter streams might influence these readings. Others speculate about large-scale structures beyond our current detection capabilities. Still more mysterious are the unexplained anomalies in both spacecraft's trajectories, tiny deviations in their expected paths that haven't been fully explained. While most experts lean toward natural causes such as gravitational pulls or unmodeled thermal forces, some believe the answers might be more profound. What the Voyager missions mean today. The Voyager program remains one of NASA's most successful and iconic endeavors. With technology from the 1970s still functioning today, the spacecraft have far outlived their original missions. Their ability to send back data across billions of miles is a tribute to the foresight and engineering behind them. But more than that, they have opened our eyes to the true scale and complexity of the solar system and beyond. From discovering volcanic activity on distant moons to entering interstellar space, the Voyagers have expanded the boundaries of human exploration. Today, scientists continue to analyze the data trickling in from both spacecraft, each bit offering a fresh clue about the nature of space beyond our Sun. With each passing year, these robotic emissaries drift farther into the cosmos, carrying with them not just instruments and circuits, but a message from Earth, a whisper across the void that we were here and we dared to explore.